Good morning everyone, I am Hazel Clintegano, and today I will be discussing about application of derivatives in real life. But before I start, let me first define our objectives. At the end of this lesson, the learner will be able to A. Determine the rate of change of one quantity with respect to another quantity, and B. Solve real-life problem of derivatives. Derivatives is defined as the rate of change of one quantity with respect to another quantity. In terms of functions, the rate of change of function is defined as derivative of y with respect to x equals f of x equals y prime. Derivatives are a fundamental tool of calculus. Derivatives have extensive application. And here, I have listed some application of derivatives in real life. The following are to calculate the profit and loss in business using graphs, to check the temperature variation, to determine the speed or distance covered such as miles per hour, kilometer per hour, etc. Derivatives are used to derive many equations in physics also. And derivatives is used to determine the rate of change of quantity with respect to another changing quantity, and to obtain the tangent and normal of a function at a point. And one of the application of derivatives is rate of change. Derivative has rate of change. The rate of change of quantity can be expressed in the form of derivatives. Rate of change of one quantity with respect to another is one of the major application of derivatives. Rate of change is usually defined by change of quantity with respect to time. For instance, the derivative of speed represents the velocity such that ds over dt shows rate of change of speed with respect to time. Similarly, if a quantity, say y, changes with respect to another quantity x such that y equals f of x, derivative of y with respect to x of f prime of x. Hence, for the function y equals f of x, derivative of y over, derivative of y with respect to x, f of x represent the rate of change of y with respect to x. In simplest way, dy over dx is the derivative of y with respect to x. So, to further understand how to apply derivative as rate of change in real-life problem, let us solve one example of real-life problem of derivatives. The problem is the volume of a cube is increasing at a rate of 9 cubic centimeters per second. Find the rate of increase of its surface area when the length of an edge is 10 centimeters. To solve, let us first give the given. Let x be the length of a side, let y be the volume, and let s be the surface area of the cube. Then x is equals to 10, v is equals to x cubed, and s is equals to 6x squared, where x is a function of time. Given that the volume of cube is increasing at rate of 9 cubic centimeter per second, therefore our given is dv over dt equals 9. So, to get the rate of volume, we need to differentiate both sides. dv over dt equals 9, then let's substitute the value of v, which is x cubed. So, dx cubed over dt times dx over dx equals 9. Then, we change the denominator. So, we can now have dx cubed over dx times dx over dt equals 9. Then, minus the dx cubed over dx. So, we can obtain 3x cubed times dx over dt equals 9. Then, times dx over dt equals 9 over 3x cubed. So, we can obtain now dx over dt equals 3 over x squared. Now, we need to find the rate of increase of its surface area when the length of an edge is 10 cm. We know that surface area of cube is 6 times side squared. So, S is equal to 6x squared. Therefore, to find the derivative of surface with respect to time, we can now have ds over dt equals d. Then let's put the value of s, which is 6x squared over dt. So next, d times 6x squared over dt times dx over dx. Then let's put the 6 into the side. So 6 times dx squared times dx over dt. So let's do the cancellation. We can now have 6 times 2x times dx over dt. Then 12x times dx over dt. We can now have 12x times 3 over x squared. Then 12x times 3 over x squared is equals to 36 over x. 4x is equal to 10 centimeter. So, ds over dt equals 36 over 10. ds over dt equals 33.6. Since surface area is in centimeters squared and time is in seconds, we can now have ds over dt equals 3.6 centimeter squared over s. Hence, derivative of surface with respect to time is equals to 3.6 centimeters squared per second. The rate of increase of its surface area when the length of an edge is 10 centimeters is 3.6 centimeters squared per second. That's how we use derivative as rate of change to solve real life problem. I hope you understand, and that would be all. Thank you.